Okay, so somebody wanted to see three questions from the homework that was assigned last week. So I'm going to answer those now one at a time in the video. The first one, this is question 4, and this is from Haese and Harris exercises on Rolle's theorem. On the mean value theorem, on the mean value theorem. And this question says to use the mean value theorem to show that there exists C in the interval 49 to 51. So the open interval between 49 and 51, such that the square root of 51 minus 7 is just 1 over the square root of C. Now that seems kind of weird. We're working with this square root graph. So what I would do in this question is simply just apply the mean value theorem and see if something like this comes up. Okay, so if we're going to use the mean value theorem, it's usually a good idea to explain why we can use the mean value theorem. And the reason we can use the mean value theorem here is that f is continuous on 49, 51 closed interval. Now, in a previous question, somebody said, how do we do that? What do we do to show this? If it's just a polynomial expression or any expression to any old power, in this particular case, we have x to the 1/2. I mean, you can just assume it's continuous. The only time you have to worry about continuity or differentiability is if it has a break in the function or a kink in the graph, so some sort of piecewise function or an absolute value function. Otherwise, just go right ahead, assume it's continuous on 49, 51, and it is differentiable on 49, 51 open interval. Again, there's no kink in the graph. It's not an absolute value. The only place in which the square root graph wouldn't be differentiable would be at x is 0, because there, as you know, the square root graph has a vertical tangent. But there's nothing funny going on in the function. Feel free to make the claim that it is differentiable and or continuous, no problem. Okay, so therefore, by the mean value theorem, so by the mean value theorem, there exists, so let's put there exists a C in the open interval, so 49 to 51, and this is such that f prime of C is, well, it's f of B minus f of A, in this particular case, f51 minus f49 over B minus A, which is 51 minus 49. So if you're thinking about probably right now, where did I get that from? Well, I've just memorized the mean value theorem. It's not on the formula booklet, so you should know that mean value theorem. In fact, I believe I said this to you guys last week before we broke up, that at one point they actually asked the question, state the mean value theorem. Okay, so you have to know that. So in this particular case, let's see, well, f prime of x, well, it's a square root graph, so it would be 1/2 x to the minus 1/2. Okay, in other words, 1 over 2 this square root of x. So we know that f prime of c is 1 over 2 the square root c, and that will equal this expression right here, okay, which we can now rewrite because we know that f is square root graph. So it's square root 51 minus square root 49 all over 2. Well, there's a square root of 51 in what we're supposed to be showing. Square root 49 is 7, so we're getting pretty close. If we just rewrite this as 1 over 2 root c is root 51 minus 7 over 2, and then, of course, there's a half on both sides, so we could just cancel that out, and you see what we got now is the result we were supposed to show, that 1 over the square root of c is root 51 minus 7, okay? We don't know what c is. It didn't tell us to find c. It just should show that a c exists. So the mean value theorem doesn't actually show you that how to find the c in order to make this particular statement over here true. It just guarantees that one exists, and that's all we're actually asked to show in the part A of the question. Okay. Now on part B, it says to graph 1 over the square root of x on the interval 49 to 64. Okay, so 1 over anything x is going to look something like this. Okay, where it's going to be some very similar graph to the 1 over x graph. In this particular case, it's 1 over the square root of x, and they're asking us to graph it, let me back up again, between 49 and 64, okay? So if we graph that, well, square root of 49 is going to be 7. This is 1 over 7. And so if you think about 1 over root 49 is 1 over 7, and then you think to yourself, okay, well, 1 over root 64 is 1 over 8. And then you look down here and you're like, oh, look, there's a 1 over 8 in the question and a 1 over 7 in the next part. You can see this is leading us up to part C. Okay, well, I'm not too sure how to get there yet. So let's just graph B and see what it looks like. So we just said it's 1 over 7 and 1/8. Okay, and 1/7, of course, is bigger than 1/8. The graph is, in fact, going down. So what's the best way to graph this? Well, we could put the y-axis in its entirety here, and then we could go like this, put a little break, and then do the x-axis, because we only want to graph this between, say, 49 and over here, it gives lots of room, there's 64, and this is supposed to be at 1 over 7, and this one's supposed to be 1 over 8. So, I mean, that's pretty good, okay? But it's coming down with some sort of curve, so trying my best to hit the next point. Then we just turn the iPad a bit here without it switching the screen around, something like that. Good enough, okay? Doesn't have to be a perfect sketch. Okay, and if you weren't sure, of course, you could use your graphing calculator. This is paper 3. You have your GTC with you. But now we have the graph for part B. Now, part C is where we have to put it all together. It says prove, hence prove that 1 over the square root of 8 is less than the square root of 51 minus 7, which is less than 1 over C. Okay, well, 1 over 7. So how are we going to get this one? Well, you can see what we have here. Maybe it's a good moment to highlight this result right here. Okay, and remember, C is, where's C? Well, it's between 49 and 51. Okay, so if we could put this maybe in a different color here, let's do it in this color red here. So we know there's 49, 51 is not very far over. It's over here someplace, 51. And our C is somewhere between there, right? And so I don't know, I'm gonna put C right here. And I know that this 1 over root 3, okay, is equal to the square root of 51 minus 7, okay? Square root of 51 minus 7 is 1 over the square root of C. What we're trying to show is this, is that, go like this, and this is C, and then I don't know how we're going to put this here. This is, move over here, 1 over the square root of C. Okay, so the mean value theorem proves the existence of this 49, of this C, somewhere between 49 and 51, such that 1 over the square root of C is actually equal to square root 51 minus 7. Aha, so you can see we got it. By the graph, we can see that 1 over 7 is up here. 1 over 8, well, I didn't quite hit that on right. Let's just move it down a bit. It doesn't really matter, it's just a sketch. There's 1 over 8. And what we know is that 1 over the square root of C is between those two. And as a result, because f prime here, 1 over the square root of x is decreasing, okay? So we can just say, well, it's not f prime, but it's close to f prime. It's 1/2 f prime. Anyways, let's say, since, how are we gonna write this up? So we're gonna say since y is 1 over the square root of x is decreasing, okay? Somebody didn't believe us that it was decreasing. Well, we could just say, well, the derivative is, well, it's a minus 1/2 x to the minus 3/2, and that's always less than 0 because x to the negative 3/2 is positive, okay? So that's why y is decreasing. So we know that, well, we know that 1 over 7 is going to be greater than 1 over 8. We actually know that anyways. We don't have to say anything about y being decreasing. And since 49 is less than C is less than 51, this will imply that 1 over the square root of 49 is greater than 1 over c is greater than 1 over 51. Of course, we're supposed to be doing this to 8, so why don't we just also add up here that 51 is smaller than 64, so this is greater than 1 over square root 51. Forgot my square root of the 51, there it is, and square root 64. So therefore we have 1 over 7 is greater than 1 over c is greater than 1 over 8, and by part A, this will imply that 1 over 7 is greater than, well, square root 51 minus 7, which is greater than 1 over 8. And we've proven it, okay? So a bit of a theoretical question, a tricky one in the sense, not a whole lot of math in there. It's just thinking, if we back up and take a look at the whole question, what I would advise when you're doing these is try and read what the question is asking you, because inside what the question is asking you is kind of the answer. When you're not sure what to do, just go with what it says. Mean value theorem, apply the mean value theorem, and try and see if your answer looks something similar to what it is you're actually trying to show. Okay? Perfect. Thank you.